Today we'll be looking at using our trigonometric ratios to find missing sides and missing angles. When we do our trigonometric ratios, you can refer back to SOHCAHTOA, which we already learned about, to give us the information about how we can set up our ratios. On number 1, if you'll look, we were given angle 30. We were also told that we had x and 10, and you need to figure out where these are in relationship to angle 30. Angle 30 is tucked in here, so if you look directly across from angle 30, that side right there is what we would call opposite from angle 30. The x here, which happens to be directly across from the 90-degree angle, would represent our hypotenuse, and then that leaves our last side as our adjacent side. So what we have been given information-wise is a 10 for our adjacent side, an x for our hypotenuse, and then an angle measure of 30 degrees. Well, when we're given hypotenuse and adjacent, look up at SOHCAHTOA, adjacent and hypotenuse go with cosine. So we're going to be using cosine here. So you want to do the cosine of your degree measure, so always the cosine of the angle measure is going to equal and set up your ratio. It's supposed to be adjacent over hypotenuse. The adjacent measure is 10. Over my hypotenuse we don't know, which is x. So now you can set this up by either cross-multiplying, or you can go ahead and solve by multiplying both sides by x so that these cancel. And then you have x cosine of 30 degrees is equal to 10. So to get x by itself, we'll divide both sides by cosine of 30 degrees. Now what happens here is these cosines cancel, and I'm going to bring this right up here to where x is equal to, and what we're going to do is in our calculator we're going to do 10 divided by the cosine of 30. Give me just a second. So 10 divided by cosine of 30 gives me a side length of 11.5. So our hypotenuse here is going to be 11.5. Let's look and compare that to number 2. Number 2, if you look, we have our angle measured here of 70 degrees right in here, and directly across from it is what we would call our opposite side. So if our angle's in here, it's directly across as our opposite side. This right here is our hypotenuse, so by process of elimination, this side here with the x is our adjacent side. So what we're given in this particular problem is an opposite of an 8, an adjacent side of x. Opposites and adjacent come right here with our tangent. So we're going to do tangent of our degree measure, so tangent of our 70 degrees is equal to the side opposite of it, so that would be the 8, over the side that's adjacent, which we don't know is x. And again, we can multiply both sides here by x, so that would give us x tangent of 70 degrees equals 8 to make our x's cancel. And then we'll divide both sides by tangent of 70 degrees. When we do that, these tangents will cancel, and x is going to equal 8 divided by tangent of 70. So give me just a second to put that in my calculator. And we get that the value of x is about 2.9. So this side length right here is about 2.9. We also learned in class how to find missing angles. Missing angles also use SOHCAHTOA. So what we're going to look at is, right here is theta. We're asked to find theta. And you want to look at what these two measures are in relation to theta. Well, if you look directly opposite of theta is this side. So this side is what we call our opposite side. This right here, directly opposite of our 90-degree angle, would be our hypotenuse, which means that 15 has got to be our adjacent side. So look, we were given information for our hypotenuse and our adjacent side. So in SOHCAHTOA, when we have the adjacent and the hypotenuse, we're going to actually be using cosine. So we will write cosine of theta, because we're trying to figure out what that angle measure is equal to, remember cosine is the adjacent side, which we found is 15, over the hypotenuse, which we found is 18. Now, in order to get theta by itself, you're going to have to do the inverse of cosine, which we show as this, cosine with a -1 in the upper right corner, and you're going to do the inverse cosine of 15/18. So you'll put that in your calculator. Make sure when you put it in the calculator, you've got the -1 on that cosine. Otherwise, you will not get the same thing. But then our angle measure is approximated to be 33.6 degrees, according to what we get in our calculator. So this angle measure is about 34 degrees. All right, let's compare that to number 4. Number 4, look at what we've been given. Here's our theta, and directly across from theta is our side length of 4. This is opposite. So this is opposite of our theta. Also, we don't know the hypotenuse, but we were given this side here, which is our adjacent. So we have both an opposite and adjacent. Opposite and adjacent means we're going to be using tangent. So we're going to go back and say we're going to do tangent of theta, because I'm trying to figure out what that angle measure is, because that's what goes right behind tangent. Tangent of theta is equal to, remember, opposite over adjacent. The opposite side is 4, over the adjacent side is 5. And to get theta by itself, we're going to do the inverse of our tangent. So inverse of tangent, and we're going to do that to our 4/5. So give me just a second. And we're going to get that theta is approximately 38.7 degrees. So this angle in here is about 39 degrees for this particular right triangle.